Alright guys, so this is the square root workshop. So we're going to be working through the problems in the packet starting on the first page. So make sure you have a packet. Make sure you have one of these square root chart or the exponent charts. The ones we'll really use are just the first two columns, the x and the x squared, just to kind of help us identify what numbers we'll be using. Alright, and then make sure you also have an evaluation to fill at the end. Alright, so when we factor, when we're gonna, not factor, I keep saying factoring, but we're gonna do the simplify radicals. Alright, and we're gonna start off with some simple radicals to simplify. So the first one we have, I'm just gonna work down in columns. So I have the square root of 49. Alright, and so if I look here on the second row of the chart, I see 49 and the x value is 7. So that means this 49 I can break down into 7 squared. And the square root and the square cancel each other. So I'm just left with this 7. I know some teachers like to see this step done, but if you know that the square root of 49 is 7, then that's okay too, just to write that down. All right. Next we have the square root of negative 81. Right. So the first thing I want to do is break this down a little bit. So I have negative 1 times 81. And what's the square root of negative 1? What's up?
Since the workshop's focused more towards 310, they have to say that that's not a real number.
What? That right?
Oh.
Yeah. Not possible.
Yeah,
Not possible?
You know 320, they get into imaginary numbers, but since
It's 310. Okay.
What you was gonna put?
I was going to put I. I. So in 320 you'll learn that. That slipped my mind.
What that mean?
It's an imaginary number.
Oh.
See what you have to look forward to in 320?
You have to deal with numbers that aren't real. All right. So this one we'll say this is not real.
Yep.
All right, it's made up. It's not really made up, but we'll just say it's not real for now.
So would it be like 9i or negative 9i?
Yes, it'd just be 9i. All right. Next we have the square root of x squared y to the 4th. All right, so when you take the square roots of variables, all we're going to do is divide these exponents in half. So kind of like here where I can square root and the square cancel. So we could also say we divided this 2 in half, so it became a 1, so 7 to the 1 power. But for when they're even powers, we're just going to divide them by 2. So this divided by 2 is 1, so I'm left with x. We can put to the first power, but typically we just say x. And for y, it's to the 4th power, so we're going to divide this by 2, so we'll have y squared. All right, so we can just write this as x y squared. All right, and the last of the easy ones, we have 25 over 81. All right. So one of the properties of radicals is that if we have a division problem, we can split, even with multiplication too, you can split up the radical. So here what I want to do is I want to break apart this large radical into smaller pieces. All right, so the square root of 25 is 5, and the square root of 81 is, and can I simplify this fraction? No, then I'm done. So you always want to try and simplify your answers. All right, so now for some fun ones. So all the ones we did for this one, they were all perfect squares. So that means in our answers, we just had whole numbers or letters. We didn't have a radical in there. But now we have something like the square root of 12. All right, and what we want to do is break this guy up. So back when I first learned about these, I had someone tell me that all the numbers or letters inside of here are in timeout, and what you're looking for is you're looking for the perfect children or the perfect squares to pull out to get out of timeout. So you don't want to punish the whole class, you just want to punish those who want to stay in there. So this is not like a parenting technique, but it's just for the math. All right. So does 12 have a factor that's a perfect square? It does. I have 4. That's right. 4 times 3. So since 4 is a perfect square, I don't want to keep them in here. What's the square root of 4?
2.
2. So one way I can do is I can break apart, just like I did with the division, I can break this guy apart. And the square root of 4 is 2. And I'm just going to leave the 3 there. I tend to skip this step sometimes, but if you want to see it, just call me out and I'll write it down. I'll try and remember to do that step. All right, next we have the square root of 72. So this one is similar. I want to ask myself, is there a perfect square times some other number that gives me 72?
9.
So 9. All right, so let's go ahead and do 9. I would have picked a different number, but we'll use 9. All right, so I have 9. So if I can split this guy up. Nine times the square root of 8, right? And so the square root of 9 gives me 3 square root of 8. Am I done? No, so I have to keep breaking this 8 down. That means that there was a bigger perfect square I could have taken out of here instead of using 9. And that's okay if we don't get it the first time, because now I can still just keep breaking this down. What does 8 break down into? That's right, it breaks down into 4 times 2. And the square root of 4 is 2. So I have 3 times 2 on the outside, and I have this lone 2 left on the inside. So he's not the perfect
So
kid.
it's what, 6 and 2?
That's right. Multiply the outside, so 6 square root of 2.
36 is what you were saying.
That's right, I would have taken out 36. So the other way you could have done it, so this is one way. The other way would just be 30. That's right. You want to try and take out the biggest number, but if you don't know it, that's fine. It's a little more work, but you can still get the same answer. Because the square root of 36, let me finish this, is 6 square root of 2. Let me change markers, because that's...
No green.
No green? Thank you. Would it be invisible?
Yeah.
That's kind of cool. All right, we'll use blue. I can't tell the difference between the two colors, so they're both easy on my eyes. All right. Next, I have the square root of 18x squared. So now I'm introducing variables into the radicals. So what I like to do when I have these is just separate them. Let's separate the numbers and separate the variables. I have the square root of 18 times the square root of x squared. So what can I break 18 into? That's right, 9 and 2. Okay. All right, and the square root of 9 is 3. That 2 is going to stay in there. And what's the square root of... What's up? No, okay. And then what's the square root of x squared? X. So you divide this guy by 2. So I'm left with 1x. And so I want to move all the stuff I'm multiplying by to the front of the radical. So I'm going to have 3x square root of 2.
That's the answer.
That's the answer. Yeah, because sometimes we're going to have letters left over in our radical. Or on the outside, as well as the inside. All right, so let's do another one. I have the square root of 125 x cubed y to the 6. I'm just moving down in the column. All right, so let's separate my letters and my numbers. So we're looking for those perfect numbers and the radicals. All right, what can I break 125 into?
5 and 25.
All right, good. We have 5 and 25. Is it okay if I keep moving this way? Okay. All right. And so for the letters, so far we've only dealt with even exponents. But here I have an odd exponent. So can I divide an odd number by 2 evenly? No. So what I'm going to have to do here is I'm going to have to move one of these letters out. So I have x3. So I'm going to bring one of those x's out. And now I'm going to have x squared. All right, because x times x squared gives me this x3. But now I have an even exponent here. All right, and I have y to the 6th power. All right, so now I want to pull out all my perfect numbers. So the square root of 25 is 5. I have the square root of 5 left over. So the square root of x squared is x. The square root of y to the 6th power is,
3.
let's write y to the 3. And then, so this guy does not have an even power. He has to stay inside the square root. So he's going to stay in there. All right. So now I need to multiply the coefficients and the radicals together. All right, so it's going to be 5xy to the 3rd power and the square root of 5x. All right, so you just move all the radical stuff together and all the stuff in front together.
Okay. Basically what's on the outside and then what's underneath the radical.
That's right. So the stuff on the outside comes together and the stuff underneath the radical. So these guys are in timeout, so you put them in timeout together. These guys go free, so they all go free. Okay. All right, next I have 180 a cubed b to the 4th power and c squared. All right, so do the same thing. We're going to separate the numbers and the letters. All right, and I have a cubed b to the 4th c squared. Okay. All right, so this one looks like it's going to be a little messy, but that's okay. What perfect square do I have in 180? I can't think of one, so let's break it down. So if I look at 180, let's see, I know I can pull a 9 out of here.
You could do a C.
Yeah, I could do a 6. Let's see. Let's see. I'm committed to this right here. So I have 9 times 20. That's a perfect square. And was there a perfect square in 20? A 4. I'm gonna have a 5. I'm gonna have a 5 left over. So 9 times 4 is what? 36. All right. So I'm gonna break this guy up into 36 times 5. So we'll just take the biggest perfect square. And if you, so I don't have a calculator with me, but if you didn't want to do this, you could just take 180. And so you know the perfect square isn't going to be a really big one, it's going to be a small one. So you could go through your calculator and you could divide out all the perfect squares. You could do 180 divided by 4, 180 divided by 5, or by 9, 16, 25, 36. Well, 9, I just, because this is 18, so I knew 9 would go into it. And then 9 and 4 give me the 36. All right. But you just, like for big numbers like this, you have to just play around with it, divide by perfect squares, and see which one works. All right. Now for the letters. The letters I think are the easy part. Do I have any odd exponents? I have 1, this guy. So I need to make him even. So I'm going to pull one of the A's out. All right. So now all these guys right here have even exponents. Right? So on the next line, what's the square root of 36? That's 6. Now he stays under the radical. And I divide all these exponents by 2. So a divided by 2 is just a. B, the 4th power divided by 2 is b squared. And this exponent divided by 2 is just c. Since he's the odd man out, we'll leave him in there. All right, and then we group together the stuff on the outside and the stuff on the inside. So I'm going to have 6 ab squared square root of 5a. All right. So I kind of burned through that little section there. Does anyone have any questions over these? Is it good so far? All right. So that was all simplifying. Next, we're going to try and do operations on radicals. So we're going to try and do multiplication, addition, subtraction, and multiplication using these radicals. So before we go into the first one, we want to talk about combining like terms briefly. So when you combine like terms, so if I have x plus 3 plus 2x plus 4, if I'm combining like terms, what do I combine? I combine the 3 and the 4 because they're just numbers. And I combine the x's because they're both x terms, right? And they're the same term. So I combine these two guys because they're both the same term, and I combine these guys because they're both the same term. When we add and subtract radicals, you want to follow that same idea. So for the first one, I have 2 square root of 3 minus 5 square root of 3 minus the square root of 3. So when we have square roots that we're adding and subtracting, we treat all of the square roots as variables. So even though it's a number, we want to treat this as a variable. So since these are all the same radical, so all the same square root 3, square root 3, square root 3, I can add the coefficients in front. So I can do 2 minus 5 minus, and what's the coefficient in front of here? A 1. So I can write a 1 in there. So I can have 2 minus 5, which is negative 3. And negative 3 minus 1 is negative 4. And when the signs are the same, we add. And we keep the common sign. All right, so when we combine like terms with radicals, you want to find the radicals that are exactly the same. Let's clear all this stuff off. Okay. So the next one is just like this. Minus 6. All right, so are all the radicals the same? And so all of these right here, they're also x terms. So I can go ahead and add them. So what's 5x plus 2x? 7x. And what's 7x minus 9x? Negative 2x. Square root of 6.
That's it?
That's it. Nothing to it, right?
To that.
All right, so let's get to one that's not so straightforward. So I have 3 square root of 8 minus 4 square root of 72 minus 5 square root of 50. All right, so none of these are the same, right? And so I cannot add them yet. What I need to do first is I want to see, can these simplify? So can I simplify this guy?
4, 2.
That's right, can I simplify this guy?
Yes.
9, 8, what was the one I did earlier? That's right, 36 and 2. And this guy, 25 and 2. All right. And so after I do this, the next step is very important because one of the biggest issues I see with this is we'll break these numbers down, but you will forget about the numbers in front. All right, we can't forget about these guys. These guys are out front. They just can't. We can't make them disappear. It's like they're like family. If we don't like them, they're still there.
That was good.
So the square root of 4 is 2, and the 2 is going to stay in there. The square root of 36 is 6. So this 2 stays in there. Square root of 5 or 25 is 5. All right. So I need to multiply all these out. So I have 6 square root of 2 minus 24 square root of 2 minus 25 square root of 2. Are all the radicals the same now? They are. So now I can simply add all these guys together. 6 minus 24. I have negative 18 root 2. Yeah, I'm running out of room here. And then negative 18 minus 25. Negative 4, 8 plus 5 is 13, 3. So I have negative 43 root 2. That one took a little more, but we had to break all these guys down first. All right, so now let's combine all this stuff together. Let's do some numbers and letters. So I have 3b, square root of 27, a to the 5th, b, minus 2a, square root of 3a cubed, b cubed. All right. So this one, so let's do the same thing we did before. Let's separate the numbers and the letters. I'm going to try and write a little smaller here so we can have some room. So here's 27. Here's a5b minus 2a square root of 3a cubed. Oops. Okay, we want to do the letters and the numbers. You have a cubed, b cubed. All right. How can I break down 27? So 9 3. 9 times 3. So are all these even? No, they're not even. So I need to take an a out of here. I have 4 a's left. Can I take a b out of here? No, so this b is he's stuck in the radical. All right, so we want to leave him there. And so these two guys, these are odd, so can I take an a and a b out of here? That's right, so I can make this a times a squared times b squared. All right, so now we want to evaluate all the square roots. The square root of 9 is 3. So I have 3b times 3. Square root of 3. The square root of 4, a to the 4th power is, that's right, a squared. I move an a and a b. So minus 2. I can't take a number out of there, so he's kind of stuck. I can take the a and the b out, right? So a squared divided by 2 is just a. B squared is b. And I have an ab left over. All right, so now for this guy and this guy, let's put the numbers in front and the numbers under the radicals together. So I have 3 times 3, which is 9. I have an a squared, and I have a b. So for underneath the radical, I have a 3 and an ab. Kind of a funny b. On this side, I just have that negative 2. I have 2a, so a times a is a squared. I have a b. Bring the 3 and the ab together. So I have 3ab. So are these the same variables and the same radical? So I have a squared b, square root of 3ab, square root of 3ab. So I can combine the coefficients. So 9 minus 2 is 7. So I did all that work just to get a 7.
My goodness.
3ab.
That's a lot of work.
It's good for the mind.
I know it is. It's really not hard once you keep going, but it's gonna wear me out on the second one. Third one. You got 6. 1, 2.
6. Okay. So does anyone have a question about these?
Simpler way to do it.
No. All you gotta do is, yeah. I mean, I could probably do this in 3 steps, but it wouldn't be very clear. It's like I break this down to all these steps to try and make it as clear as possible.
Oh, you did a good job.
All right. So that's adding and subtracting. So next we want to do multiplication. So I have 3 square root of 6 and 4 square root of 3. All right. So kind of like with adding, when we add, and you have to add the stuff in front and the stuff on the inside, right? So like here, when we combine these, you combine the stuff on the inside and the stuff on the outside. So, and this is multiplication. This is, I didn't explicitly state it here, but this is what we're going to do when we multiply. So when you multiply, you just put the stuff on the outside together and the stuff on the inside together. So we're going to do that right here. So the stuff on the outside is 3 and 4. So 3 times 4 is 12. All right, and the stuff on the inside is 6 times 3, which is 18. All right, and so just because you can't simplify here doesn't mean we can't simplify here. So what does 18 break down into? So we got 2 and a 9. Okay. So the square root of 9 is 3. So I have 12 times 3, square root of 2. And 12 times 3 gives me 36. All right, everyone okay with that? So let's make some room for me. All right, now we have the square root of 2, square root of 3, minus 2, whoops, square root 2. All right, so for this one, so here we just multiplied 2 numbers. Now we're going to use the distribution property. So I have this square root of 2 on the outside, and I want to multiply it to everything on the inside. All right, so square root of 2, so we're going to follow the same rules, inside times inside, outside times outside. So what number is on the outside of the square root? a 1. So we could write that 1 out there if we wanted to kind of help ourselves out there. All right, so here I have a 1 times a 1, so this would be 1. And the square root of 2 times square root of 3 is square root of 6. And you could write the 1 on the outside if you'd like. Over here I have 1 times negative 2. Square root of 2 times square root of 2 is square root 4. And then we see if we can simplify. I can't break this guy down, but I can break this guy down. So I have negative 2 times 2. And 2 times 2 is 4. So it's square root of 6 minus 4.
That 6 is minus 6 minus 4 because that negative is minus.
That's right. Yeah, this is negative because of this negative right here. So we did positive times a negative gives us that negative. All right. So let's do some more with distributing. Let's use FOIL. So I have square root of x plus 7 times the square root of x minus 4. All right, so when you have two binomials that multiply, we can use FOIL. So I want to do the first two terms. So the square root of x times the square root of x is square root of x squared. We do the outside. Square root of x times negative 4. Negative 4 square root x. And don't forget the square root. Remember, you multiply the inside times the inside, outside times outside. So there is no square root here, so I'm just going to throw the square root onto the end of this number. And the front number is a 1. So 1 times negative 4 gives me a negative 4. All right, then we do the inside. So 7 times square root of x is just plus 7 square root of x. And then do the outside. 7 times negative 4. Okay. So we're going to simplify and combine like terms. So this guy simplifies to what? That's right, because remember it's to square root, you divide the exponent by 2. So 2 divided by 2 is 1, so I have x. Negative 4, so here the radicals are the same, so negative 4 plus 7 gives me negative 3 square root x. And over here I just have negative 28. He's just hanging out at the end. Right, and that's it. I can't break anything else down. I can't combine like terms. This will be my answer.
She want to know where you get that negative 3 from. 7 minus 4.
So what's negative 4 plus 7? Oh, you're right. It is positive. Okay. Oops. Thank you. That's right. Negative 4 plus 7 is not negative 3. All right. Negative 3 squared. So I'm going to do something here, and you tell me if I'm right or wrong. So I'm just going to go Am I good? One person says I'm wrong.
You gotta write it twice.
That's right. So when you square something that has addition or subtraction there, you need to square it twice.
You gotta write the same product twice.
That's right. So we don't want to square both of these. And when you square something, like 2 squared is 2 times 2. So you're multiplying whatever you're squaring by itself twice. So I want to multiply this by itself. right?
Like the whole.
Try the whole thing twice. And we're going to do what we did just up here. I have two binomials, and they're multiplied together, so I can use FOIL. So we do the first. So 3 times 3 is 9. Square root 2 times square root 2 is square root 4. We do the outside. 3 times negative 1 is negative 3. Square root 2 times square root 3 is square root 6. Then we do the inside. Negative 1 times 3 is square root 3 times square root 2, square root 6. Then I do the not the outside, the last. All right, so a negative 1 times a negative 1 is a positive 1. And square root 3 times square root 3 is square root 9. So now I want to simplify any radicals and combine like terms. So here I can simplify this guy. So this is 9 times 2. Negative 3 minus 3. It's negative 6, square root 6. And the square root of 9 is 3. And 9 times 2 is 18. I just need to combine like terms now. 18 plus 3 gives me 21. All right. So this is all multiplication. So any questions on the multiplying? All right. So there's no questions. We'll move on to dividing. So we really don't call it division. When we say when you have, it's normally written in fraction form. So like this first problem. So usually we don't call it division, but we have this problem right here when this is technically division, but what we want to do is we want to get all the radicals out of the denominator. Now there's a lot of ways you can do this. I like to go the simplest possible. That's right. And so to make this easier on myself, what I would do is I would reduce. So the first thing I know, A can go into 24 how many times? 3 times. So this becomes a 1, this becomes a 3. Can I break this into a square root of 10? I can. 4 times 10. I want to make this as easy on myself as possible. And then one of the properties of square roots is if you have multiplication, I can break up the square root. So what do I have that's common on the top and the bottom? Square root 10. That guy's gone, right? So that means all I have left is 3 times the square root of 4. What's the square root of 4? 2. So that's just 3 times 2. So it won't simplify this nicely for all of them, but I always like to just break this down and make it just as easy on myself as possible. All right, try and get this guy to reduce. He won't always cancel out, but you can reduce him. All right, so this guy right here. Here's an example of someone I'm just kind of stuck with the radical. I can't break down the 6. I don't have a square root on the top to help simplify him like I did here. So to get rid of him, I want to multiply. So we want to rationalize this. So I want the square root out. So to get rid of a square root, we have to have a perfect square, right? So to get the guy out of timeout, he has to be perfect. How do I make this guy perfect? By 6, right? So if I multiply him by 6, what's 6 times 6? And 36 is a perfect square. So whatever I do to the bottom, I have to do to the top as well. So I have 3 square root of 6 all over the square root of 36. That's right. The square root of 36 is just 6. And then before I move on, can I simplify? That's right, I can reduce the 3 and the 6. 3 goes into 6 2 times. There's a 1. So I have square root of 6 all over 2. All right. So is it okay so far? I don't know if y'all have seen that first one where you break down the radical. Was that all right? Good. Okay. So next I have the square root of 2/5. So it's kind of like the one in the front. The square root of 81 over 49.
You might have an older copy. Copy the ones that Zach is doing. They might have an older copy.
Okay.
48 2/3.
Okay. We'll just do this one. So just write in 2/5.
Right 2/5?
Yeah, just write 2/5. So if the problems don't match up, just write the problem I put up here.
Okay.
All right. So one of the properties of radicals is that if you're multiplying or dividing, we can separate the square root. So I can write this as the square root of 2 over, that's right, the square root of 5. So then we have a problem similar to this one right here. So to get the radical out of the denominator here, I had to multiply top and bottom by whatever was in the denominator. So I want to make it a perfect square. So I'm going to multiply the top and bottom by the square root of 5. That's right. So I'm going to square root 10 on top over the square root of 25. That's right. So the square root of 10 all over 5. Can I reduce that 5 and 10? Good. You cannot, because the 10 is inside the radical and the 5 is not. So those, if you're in timeout, you don't want to, or if you're not in timeout, you don't want to mess with someone who's in timeout. Next I have the square root of 48x cubed all over 7y.
That's the same way we just did that.
You can break it up. The first thing, the first thing I do is see if anything can simplify in here. That's right. Well, yeah, this one can break. We can break up this top guy. But let's break this guy up first. So I have square root of 48 x cubed over the square root of 7y. All right, and so I can simplify this guy just so I don't have something like a beast of a number to deal with. So this is 3 times 16. And since this is an odd number, I can take an x out and make it x squared. All right, and so let's take some square roots at the top. So the square root of 16 is 4. The square root of x squared is just x. And then I have a 3 and an x left over on the inside. Okay, now we have that done. I still need to get rid of this guy. So just like I did with the last couple problems, I'm going to multiply the top and the bottom by whatever is in the denominator. Okay. Remember when you multiply radicals, you only multiply radical to radical.
Oh, yeah.
So I still have just this 4x out here.
Be 3.
So 21xy.
Simplify.
Square root of 49 y squared. So we went from this step to this step. That's right, multiply across. 7 times 7 is 49, y times y is y squared, 3 times 7 is 21, and x times y gives me xy. All right, so next I can't simplify this guy anymore, so I just want to simplify him. So the square root of 49 is,
7y.
and so 7, and the square root of y squared is y. So I have 4x, 21xy, all over 7y. Can I simplify it any further? No, I cannot. So any questions on dividing radicals? Good. All right. Okay, last page. So we got a couple minutes. Let's do a couple. I didn't realize what time it was. All right, so we want to solve equations with radicals. So the first one. So this is just like solving equations with a variable of x, except we just have a thing like just two or three extra things we tack on to here. The first thing is we want to isolate our radical. So whenever you have an equation, so if you have an equal sign here, and we have a square root of a variable, I want to isolate this square root. So to isolate it, I need to divide both sides by 3 first. So I have the square root of x, and 3 goes into 18 6 times. Now to get rid of this square root, I need to square both sides of my equation. All right, so this gives me x, so the square root and the square cancel. And 6 squared is 36. Now one of the big issues with radicals is we need to go back and check our answer to make sure it's actually a solution to this problem. So you want to check, so I go back to the original problem. Wherever there's an x, I'm going to plug in my answer. So there was an x right here, so I'm going to plug in 36. And it's supposed to equal 18. So the square root of 36 is 6. And 3 times 6 is 18. So I get 18 on both sides, so my answer checks out. All right. So the square root of 5x plus 1 equals 4. All right, is the square root isolated? It is. I don't see a number added or multiplied to this guy. So I can go ahead and I can simply square both sides. So the square and the square root cancel. I'm left with 5x plus 1 equals 16. Just move the 1 over. All right, so I have 15. These are gone, and I have 5x. Divide both sides by 5. I have x equals 3. All right. And just to give us time to do one more, this will check out. You can go ahead and check this on your own time. If you plug this in, you will get 16, the square root, and the square root of 16 is 4.
There's a class coming in after this.
Yeah.
How would be the last one?
Last one? All right, so let's skip on down to the last one. All right, so the one at the very bottom, I have it's the square root of 3x plus 1 is equal to x minus 3. All right, is the radical isolated? All right, the radical is isolated, so to get rid of it, I need to square both sides. So here the square root and the square cancel. So I have 3x plus 1. That's right. And so remember, when this thing's squared, I have to write it twice. Don't put down x plus 9, x squared plus 9. So I need to write this guy out twice. My next step is to FOIL. So I do first, outside, the negative 3x, inside, negative 3x, and the last, which is positive 9. That's right. Next one to do is combine like terms. That's 9. And since I have an x squared term, this means I need to factor. So I need to set this thing equal to 0. So I want to move these two guys to the right side. So these two guys are gone. I have 0 on this side. We can bring him down. Negative 6 minus 3 is negative 9. And 9 minus 1 is 8. All right, now I have a simple factor. So I'm going to break down my two parentheses. And so what two numbers multiply to give me 8 that add to 9? Well, it's going to be 1 and 8. And since this is negative 9, both of these need to be negative. And this goes back to factoring. And because there's an x squared term here, I need an x and an x. All right, and I need to set both of my factors equal to 0. All right, so I have x minus 1 is 0, x minus 8 is 0. All right, move the 1 over, move the 8 over. So I have x equals 1. Oops.
Were you checking
I'm still solving for my solutions. And x equals 8. Oh man, all right. So now I have this. So now, whenever you have an x, so just like the other problems, we want to check our solutions. So let's go ahead and check 1. These ones are a little bit work intensive. So I go back to my problem, I plug in 1 for all the x's. All right, and we just start simplifying. 3 times 1 is 3. 3 plus 1 is 4. 1 minus 3 is negative 2. So I'm going to stop right there. Is the square root of 4 negative 2? No. When we deal with just a square root, we deal with the positive value. So because this square root of 4 is positive 2, and these two are not the same, that means I get to throw away that 1. That's what we call an extraneous solution. All right, so that's why we want to make sure we check our answers for square roots, because sometimes we get these extra answers that don't make sense in our problems. All right, and then next I want to check 8 to make sure it works. Square root of 3 times 8. Eight minus 3. So 8 minus 3 is 5. So 3 times 8 is 24. Plus 1 is 25. And the square root of 25 is 5. So 8 checks out. So 8 for this equation here is our only solution. Okay. All right, that's it for the workshop.
Thank you.
Thanks for coming, guys.